Okay, question 8 is pretty much the same as question 7, but now we have this added value of 0.2 for our coefficient of friction. So again, we're going to look at the whole system first to see what happens. And in real life, for all we know, these could be 3 different materials. They'd have different friction values, but we're just going to assume it's all the same contact material between each box and the surface. So we have our total mass is being accelerated by some quantity. We don't know what it is. And it's being pulled forward with 45 newtons. But this time it's being opposed by friction. So again, we can think of it as each individual one, or we can do them all separately. So we could do minus force of friction 1, minus force of friction 2, minus force of friction 3. So you could do them all separately, or we can combine them together. We'll get the same answer. So we have 15.00 kilograms being accelerated by some amount. How much acceleration is based on how much we're pulling forward, 45 newtons, minus the coefficient is 0.200. And our equation for friction is force of friction is the coefficient multiplied by mass times gravity because it's a flat horizontal surface. We'll get into scenarios next day. What happens when the acceleration is angled downwards or upwards? It does affect the normal force. But for now, flat horizontal surface, normal force is mass times gravity. So 15 kilograms times gravity 9.81. So 45 minus 0.2 times 15 times 9.81. And divided by 15, we get an acceleration of 1.038 meters per second squared. So 1.04. Okay, now we can go ahead and solve for our, the tension force. So again, if we think about our free body diagram, our forces, like last time, we have some T1, T2, so that's also T1, sorry, T1, T1, T2, T2. There's also this force of friction 1, force of friction 2, and force of friction 3. So when I look at the first block, it's being pulled forward by 45.0 newtons, and there's some T1 pulling backwards and some force of friction pulling backwards as well. So this 45 newtons is overcoming both the tension and the force of friction forces to cause this whole system to accelerate at about 1 meter per second squared. So we have mass of block 1 is being accelerated by 1.038 meters per second squared. The 45.0 newtons is making it go right, but it's overcoming tension and force of friction 1. So the mass was 5.00 kilograms, acceleration 1.038 meters per second squared, 45.0 newtons minus T1 minus, you be careful, we're not just going to use this whole friction value before, we're just looking at block 1. So it's the 0.200 multiplied by the 5.00 kilograms times G. So now you can solve for T. That's 45. I'm going to subtract that friction, 0.2 times 5 times 9.81. And we also subtract that 5 times 1.038. And lo and behold, we get our tension force, which is T.0 newtons. When we have a flat horizontal surface, it does work out that the no friction scenario does give you the same tension values for a friction scenario. We do the last one, we have that 5 kilograms at the end. Let's think of block 3. Block 1 was the first one. T2 minus the force of friction 3. So M3 times A is equal to T2 minus our force of friction 3. 5.00 kilograms times 1.038 meters per second squared. T2 minus that 0.200, 5.00 kilograms times G. So 5 times 1.038 plus 0.2 multiplied by 5 times 9.81. And as expected, 15.0 newtons.